Hi guys, welcome back to my mathematics tutorial. My name is Peter C. Duckworth Jr., your math tutor, and I am an instructor of mathematics at the University of Liberia. In our today's lesson, we want to continue from where we stopped in previous lesson, that is finding derivatives of trigonometric inverse function using trigonometric substitution. So we want to find the derivative of this function with respect to x using trigonometric substitution method. So we told you in previous lesson, whenever you are to use trig substitution method, you must be able to rewrite the expression within the angle as the same expression of the given function. So if this is tangent inverse, it means you need to rewrite this expression as tangent of an angle, tangent of some angle. If this is sine inverse, you must rewrite this as sine of some angle, such that tangent inverse of tangent of an angle is equal to that angle. So now, again, an emphasis has to do with understanding the trigonometric identities. So we need to think of trig identities that can make this expression to just be equal to some tangent of an angle or whatever angle. Now, so there are several ways that we can approach this problem, right? So one way one method, we could decide to rewrite each of these, right, in terms of some trigonometric identities that will lead to tangent. So what do we know? We know that cos square x minus sine square x is just equal to cos of 2x. This is what we know. This is the double angle identity for cosine. Now, how do we get that 1 minus cos of x and 1 plus cos of x? If we rewrite this expression, thereby bringing in the Pythagorean identity for cos square x, which is 1 minus sine square x, we will now have 1 minus 2 sine square x, or equals to cos of 2x. Now, if this expression, if this 1, or assuming this cos of 2x, this is 1. If this cos of 2x come on this side, we have minus cos of 2x. And then we send this one across, it becomes 2 sine square x. 1 minus cos of x. But here we have 1 minus cos of 2x. So we can divide this angle by 2 and divide this angle by 2. Right? So therefore, we will have 1 minus cos of x is equal to 2 sine square x over 2. So there's the first identity that we know. So let's put it right down here. Cos of 2 sine square x over 2 is equals to 1 minus cos of x. Similarly, if we replace sine with the Pythagorean identity, which is now 1 minus cos square x. Now, remember, because of this negative, we must put this in parentheses. So negative times 1 will give us negative 1, and negative times negative will give us positive, right? So now this plus this gives us 2 cos square x minus 1 equals to cos of 2x. So we need 1 plus cos of 2x. So if we send this is negative. If we send it across, it becomes positive. So 2 cos square x is equals to 1 plus cos of 2x. But we don't need 2x. We need just 1x. So we can divide each angle by 2. So 2 cos square x over 2 is equal to 1 plus cos of x. So this is another identity that we have. So we have 2 cos square x over 2 is equal to 1 plus cos of x. Now let's go and do the substitution. So we have y equals to tangent inverse square root of, in the numerator, we have 2 sine square x over 2. In the denominator, we have 2 cos square x over 2. So y equals to tangent inverse of, what do we have? This 2 can cancel this 2. Sine and cosine, they both are square. So we can say sine of x over 2 over cos of x over 2 raised to the power 2. So this will cancel the square root. So y equals to tangent inverse of sine of x over 2 or over cos of x over 2. What is sine over cos? Sine over cos is the quotient identity for tangent. So this is tangent of x over 2. So tangent inverse of tangent of x over 2 would just be equal to x over 2. Now, because we were asked to differentiate with respect to x, we can now differentiate. So we say dy by dx is just equal to, what's the derivative of x? Now we can bring this 2 outside. What's the derivative of x? Derivative of x is just 1. Right? That's just 1. So now we have dy by dx is just equal to 1 over 2. So this is how we find the derivative of the trigonometric inverse function using trigonometric substitution method. So thanks ever so much for watching, and see you in our next lesson. Thank you.